Dear listeners, in this presentation, we will talk about designing buildings and structures using information modeling technology. We would like to introduce you to Renga BIM software, which is dedicated to the architecture, engineering, and construction sectors. The presentation will consist of several sections. We will talk about the company that develops Renga's functionality for designing buildings and structures for various purposes, and the advantages of using Renga. Firstly, we will provide you with key information about Ascoin. The Ascoin Group is an IT company. It has been on the market for more than 36 years. The company's software is used on over 10 million devices every day. The company operates in two main areas, construction and mechanical engineering. Developing BIM solutions is one of our company's key areas of activity. The Ascoin BIM solution consists of two main products: Pilot BIM, a common data environment and the single, reliable source of information for a project team. Renga, a BIM system for the architectural, structural and MEP engineering design of buildings. If we consider the products throughout a building's life cycle, Renga will cover the initial design stage, from sketches to detailed design. The Renga BIM model, created during the design stage, can be actively used at the subsequent stages. Pilot BIM, as a common data environment, covers all stages and is used effectively during the planning and design phases, as well as during the pre-construction, procurement, construction and post-construction phases. In this presentation, we will focus on Renga's functionality. With Renga, you can create 3D models of buildings and constructions of various types and shapes. Our product team is focused on making our BIM software simple and accessible to everyone. Renga is easy to use and can solve all design tasks. It is based on a proprietary geometric kernel. We will now show you a video demonstrating the system interface and the design sections. Renga is a BIM system for integrated design. Users can create architectural projects, structural projects, 3D models of internal engineering systems, such as water supply and sewage, heating, ventilation, electrical networks. They can also work with process equipment. One of Renga's main advantages is its unique real-time collaboration functionality. It works in a similar way to Google Docs. If your colleague adds an object to the model, you will see this object immediately. In Renga, all project members work in a single environment with the same 3D model. Each project team member can track the changes that their colleagues make. This reduces the chance of collisions between architectural, structural, and MEP solutions and reduces the time taken for model coordination. Let's take a look at the tools available for each specialization. Renga gives architects the opportunity to complete all tasks of the design stage, from working with sketches of space planning and interior solutions to creating detailed plans and drawings, and transferring the project to rendering apps. You can create a limitless number of classical and modern architectural building forms, as well as working with complex architectural forms. We will now show you projects created by our users with Renga tools. Residential complexes. Different types of individual residential buildings. Renga is widely used for designing schools, universities, kindergartens, hospitals, stadiums, restaurants and shopping malls. It's also good for 3D modeling of plants, factories, warehouses and staff modules of industrial buildings. Moreover, it is possible to make reconstruction projects of cultural heritage objects in Renga. Renga objects are created using the Universal Object Creation tool, Styles. To create a new object, simply select the appropriate base object and change the specified parameters for this type of element. This means you become independent of catalogs of equipment from various manufacturers. Let's see how this works. Renga provides architects, design engineers and internal network engineers with tools for the rapid creation and editing of objects. All Renga objects can be created in under a minute thanks to the built-in Styles tool. To create a new object, click the Manage Styles button on the primary panel. Select the required object type, for example, Windows Styles. In the Windows Styles editor, create a new style. Then, on the right of the window, add vertical and horizontal mullions. Specify the parameters. Click OK. Now place the created window in the model. On the Tools panel, click the Window tool. Set the window style and specify the window parameters. Finally, select where to install the window in the wall. In Renga, it is possible to create objects with different levels of detail. These range from elements with decreased level of geometric detail to complex elements with a higher level of detail. Users can also work with imported objects. The system allows users to import 3D models of solid and polygonal geometry, as well as IFC files. Architects can assign custom parameters and properties to imported objects, or modify their geometry. All elements, together with their parameters and properties, will be reflected in the drawings and taken into account in the schedules. One more important feature for architects is the ability to work with textures. Let's now see how this is implemented in our BIM system. The visual style of a model and its drawings can be represented in wireframe, monochrome, color or textured ways. When you select textured, the textures assigned to materials are displayed on object surfaces. To assign textures to materials, click the Manage Styles button on the primary panel. Go to Materials. Create a new material or select one to which you want to assign textures. In the Textures tab, specify an image file in PNG or JPEG format. And set the parameters of its display on Renga objects. Click OK. The texture will then be displayed. This was a brief introduction to the basic functionality required to create architectural 3D models. We will now smoothly move on to the next section. Renga provides design engineers with tools for designing monolithic concrete, precast concrete, metal and wooden structures. Two types of structural reinforcement are available for cast-in-place reinforced concrete structures: automated and manual. The automated reinforcement tool significantly speeds up the distribution of rebar in cast-reinforced concrete elements. To use this option, users need to set a reinforcement style. This is a set of rules based on reinforced concrete structure design standards that can be customized by users. In accordance with these rules, Renga will strengthen structures. The following video will demonstrate the automated reinforcement tool. In Renga, you can automatically reinforce objects using the Reinforcement Styles tool. To use this option, select the objects you want to reinforce, go to the Reinforcement Styles tab, select an existing style or create a new one by specifying the reinforcement rules. You can use different methods of reinforcement. Reinforcement with rebars in a given object and ready-to-use reinforcing meshes and cages. Finally, click OK. Renga will reinforce the selected objects. Another Renga option is to work with precast concrete structures. The profile editor can create profiles of any type and shape for precast concrete structures. Renga provides tools for detailed 3D connection design and creating metal rolling assortments, plates and holes of any type and shape for those who design metal structures. Let's take a look at how users work with metal structures. In Renga, the main tool for working with metal structures is the Assembly tool. It is used to insert a group of objects created in the Assembly Style tab into a model. In this tab, you can arrange the main objects for modeling metal structures, columns, beams and plates. Standard profile forms can be used for columns, beams and plates. For example, a rectangle, an ellipse or a T-shape. You can also use the profile editor to create structural elements with non-standard profiles. To insert an assembly into a model, select the Assembly tool. Specify the parameters. Select the assembly insertion point. If necessary, it is possible to convert the selected assembly into individual objects. For that, use the disassemble action. The same principle can be applied to working with wooden structures. The next section is the internal engineering systems section. Renga provides users with tools to design water supply and sewage systems, heating systems and individual heat points, ventilation systems, internal electrical systems and low-current networks. There are several ways to create MEP equipment in Renga. The easiest method is to use the Universal Styles tool, which can be used to create all the necessary types of equipment of any manufacturer. The second option is to apply basic programming skills and use a domain-specific language to create complex equipment. This enables you to develop BIM catalogs in accordance with your company's internal standards. Any created equipment is automatically connected to the engineering systems using the automatic tracing tool. This tool automates MEP system tracing in accordance with the geometry of rooms. Watch how this tool works. In Renga, you can automatically route pipe systems, duct systems, and electrical systems. To use this option, specify the equipment you want to connect to the engineering systems. Select the equipment in the appropriate system tab. Set system parameters configuration. Click OK. Then determine connections between objects in the tab with a system. Renga will automatically generate the sewage route. During the routing process, the program considers the architectural section objects, such as walls, foundations, beams, columns, windows and door openings. You can edit the result in 3D view if necessary. The final section is the industrial equipment and process design section. Renga can be used as a solution by construction technologists. To design complex technological objects, you need to create process equipment and lay technological lines using the automatic tracing tool. At the end of the design process, drawings, specifications and sheets are released. The built-in drawing editor automates the creation of project documentation. Floor plans, elevations and sections are automatically retrieved right from the 3D model. The schedule tool is used to perform accurate structure volume and material quantity calculations. This tool automatically collects object data and generates reports in table format. If changes are made to the 3D model, the schedules will be recalculated automatically and the drawings will be updated as well. Automatic generation of axonometric diagrams is additionally available for internal engineering systems. We understand that, when working on a project, specialists may use different tools to solve specific tasks. To avoid problems with exchanging data between all the programs used, you can import and export the Renga model in a wide range of formats. Solid file formats such as JT, STEP, Parasolid, and IFC for the following Open BIM approach. The ability to import and export in DWG and DXF formats helps you to interact with other CAD systems. You can also import DWG, DXF or vector PDF data into a drawing or insert it as an underlay in the 3D view. In conclusion, there are a few points to mention. Renga offers different types of licensing. You can choose the one that best suits your needs. We provide new tools for our users every month and half and implement new features within the shortest possible time frame. Our technical support specialists are always ready to assist you. The Renga BIM system has an open API. This means that you can develop your own applications. Renga is a modern system. Its file format is lightweight. To help users get started with Renga quickly, we are developing a series of courses. Scan the displayed QR code to find them. Join us. Visit our website to try the Renga trial version.